Good day, everyone. Today, we are going to learn few things on our report regarding miscellaneous materials under the subject of Construction Materials and Testing, or CMT. So, let's start. This report includes the following report contents. First, understanding the miscellaneous materials, reinforcing steel and masonry unit. Then further discussing about tensile strength of reinforcing steel bar, and lastly, the masonry unit, which encompasses absorption and moisture content of concrete masonry unit and compressive strength of concrete masonry unit. Miscellaneous materials or other materials need to be tested other than the aggregates, cement, and concrete. It is a collection or group composed of members or elements of different kinds. Miscellaneous material means building material on structural components, and in this topic, we will focus greatly on reinforcing steel bars and masonry unit. Both of these are essential factors needed to be considered in order to ensure the quality control of your project. Since these are part of structural components, it plays a huge role on the building's construction and stability.
Reinforcing steel bars, also known as reinforcement steel or rebars, are used in reinforced concrete and masonry structures to strengthen and hold the concrete in tension. Kaya rough and may pattern yung surface ng rebars ay para ma-improve yung quality ng bond nito with the concrete. Its uses include providing resistance to support design loads by spreading it to a wider area, localized resistance to limit cracking, assisting other bars by holding them in place. Sa halip na solohin ng concrete yung bigat or load, nakatutulong yung rebars na ma-distribute yon. Tumutulong din yung rebars na i-hold in place yung ibang mga bakal. So ano naman yung tensile strength? Tensile strength is a material's resistance to pulling or a tensile loading. Dinidictate nito yung maximum stress na kayang i-handle ng isang material without permanently deforming or breaking. Malalaman ng tensile strength ng isang material sa pamamagitan ng pag-divide ng force or load over the area. Tensile strength of reinforcing steel bars. Rebars are used to improve the tensile strength of the concrete. By casting rebar into concrete, it is able to carry tensile loads and so increase its overall strength. While concrete is strong in compression, it is relatively weak in tension. Dito pumapasok yung tensile strength of rebars. Dahil nga patterned yung surface ng bakal, nape-prevent nito yung pag-split up ng concrete and nade-decrease yung speed at which failure occurs.
Tensile strength testing procedure is done to determine the tensile strength, yield strength, event ductility, and reduction area. The first step is to measure the diameter of the steel on the test piece. Complementary scale shall be marked along the whole test piece, but we need to make sure that the marks we made could not result in premature fracture of the test piece. The next step is to grip the test piece in the jaws of the test machine. Ensure that the pieces are held in such a way that the force is applied as actually as possible. Next is to apply the load in the test piece until it reaches its maximum strength and breaks. After fracture, put down the maximum force, measure the final gauge length, and minimum diameter after fracture. From stress-strain diagram, find the force at the point of yield. And lastly, determine the tensile strength, yield strength, percentage elongation after fracture, and the percentage reduction of the area.
There are many types of material standards, and among these are American Society for Testing on Materials International, also known as ASTM, Canadian Standard Association, also known as CSA, European Standard, also known as EN Eurocodes, British Standards, also known as PS, and Indian Standards, also known as IS. Among these standards, the most used standard in material testing is the ASTM. Then there is also one in our country known as the Philippine National Standard, or PNS, where mostly the standards are adopted from ASTM. As shown here, here is the ASTM standard for tensile strength, yield strength, and elongation for grade 60 and grade 75 bars. These are the ASTM International Standard based on its size and measurement requirements. Now shown here in the next slide is the European Standard of size and measurement requirements of rebars. We can see on European standards, it is measured based on their cross-sectional instead of their nominal area. And here is the Canadian rebar size and dimension standards.
Concrete unit masonry is a form of masonry which uses prefabricated concrete blocks, including hollow or solid architectural concrete masonry units, or CMU. To be considered solid, units must be at least 75% solid. Hollow concrete units are preferred because of their reduced weight, easier handling, and lower cost. Concrete masonry units are made from hydraulic cement, water, and mineral aggregates with or without the inclusion of other materials. CMU are molded using a relatively dry mix of cement and aggregates. They are compacted and consolidated using low-frequency, high-amplitude vibration and then cured under controlled temperature and humidity. These units are suitable for both load-bearing and non-load-bearing applications.
The moisture condition of aggregates in concrete is very important. Compressive strength of concrete is dependent on the ratio of mass of water to cementitious material, but what isn't understood as well is that the water-cement ratio controls the pore volume and pore sizes in the concrete, thereby determining not only the strength but also the durability. In the laboratory and when designing concrete mixture, we really talk of only two moisture conditions. The first, oven dry, means exactly what it sounds like. The aggregates, which contain pore spaces of their own, have those pore space filled only with air. The second, saturated surface dry condition, is defined as the condition in which all of the pore space within the aggregate is full of water, but no water is present on the surface. Both of these are laboratory definitions. In practice, aggregates in stockpiles, plants, and in the mixture are rarely, if ever, at these moisture conditions. The absorption of aggregate indicates that the quantity of water which will be absorbed into the pore structure. Most commonly, aggregates will have a moisture content that is either below or above this absorption limit. When batching, it is of critical importance to account for this water. Obviously, if the aggregates are in the surface wet condition, meaning moisture content is greater than the absorption, that surface water increases the water to cement ratio and affects strength and durability. Measuring and compensating for moisture in the aggregates is a critical part of any quality control process. If the means and method are not available to measure the moisture content of the aggregates, at least estimating by reviewing the stockpile is better than ignoring this input in the batch computer.
Determination of water absorption of bricks. The water absorption percentage of bricks is calculated with the help of sensitive balance and ventilated oven. The sensitive balance should be capable of weighing within 0.1% of the mass of the specimen. The required sample of bricks is taken from the stack. The specimen is kept in a ventilated oven at a temperature of 105 to 115 degrees Celsius till it attains substantially constant mass. Take the specimen and cool it under the room temperature. Obtain its weight, that is M1. Now, immerse the completely dried specimen in the clean water at a temperature of 27 plus or minus 2 degrees Celsius for 24 hours. Remove the specimen and wipe out any trace of moisture. Obtain the weight, that is M2 of the specimen after 3 minutes from the removal from water. Then, water absorption percent by mass is calculated by the formula M2 minus M1 divided by M1 into 100.
Note that when you take M1, if the specimen is warm while touching, it shall not be used for the test. Test it when you feel it cool. In testing, if the water absorption test has failed, obvious reasons are poor manufacturing, insufficient burning, and etc. And if the specimen fails in water absorption, never ever use such a specimen because you can't resolve the problem by any treatment or remedies in the future.
Maximum permissible water absorption is shown in the table. Absorption is a measure of the total water required to fill all voids within the net volume of concrete. It is determined from the weight per unit volume difference between saturated and oven-dry units. Aggregates with relatively large pores, such as some lightweight aggregate, have a greater absorption than dense, non-porous aggregates, given the same compaction. As a result, lightweight units are permitted higher absorption values than the medium or normal weight units. Because concrete masonry units tend to contract as they dry, C90 limits their potential drying shrinkage to 0.65% measured using ASTM C426. Dimensional tolerances and finish and appearance requirements are similar to those in C90, with the exception that chip size is limited to 13 mm.
Compressive strength tests are used to ensure that concrete masonry units meet the minimum strength requirements of the applicable unit specification. The unit compressive strength results may also be used to verify compliance with the specified compressive strength of masonry when using the unit strength method.
So makikita sa video na yon kung paano nga ba nakukuha yung compressive strength ng isang testing. And meron tayong ginagamit na machine. Una is yung compression only test machines kung saan compressive strength lang yung pwedeng makuha dito. And meron din namang universal test machines kung saan bukod sa compressive strength, pwede rin makuha yung tensile strength ng isang concrete kung gagamitin yung machine na to. The compressive strength is calculated by CS is equals to F divided by A, where F is the force or load at point of failure and A is the initial cross-sectional surface area. The strength of concrete is controlled by the proportioning of cement, coarse, and fine aggregates, water, and various admixtures. And pwede pang mas madagdagan yung strength ng isang concrete depende sa kung ano yung ilalagay na admixture. The ratio of the water to cement is the chief factor for determining concrete strength. The lower the water-cement ratio, the higher is the compressive strength.
Compressive strength of masonry based on the compressive strength of concrete masonry units and type of mortar used in construction. All concrete masonry units complying with ASTM C90 reference number 7 have compressive strengths exceeding 1900 psi or 13.1 megapascal. By the unit strength method, any C90 unit used with type M or S mortar can be used for projects that have specified compressive strength of masonry values up to 1500 psi or 10.3 megapascal. If used with type N mortar, any C90 unit can be used for projects having specified compressive strength values up to 1350 psi or 9.3 megapascal. Conversely, if the concrete masonry units have compressive strengths of 2800 psi or 19.3 megapascal, then the maximum specified compressive strength used in design would be 2000 psi or 13.8 megapascal if type M or S mortar were used. Similarly, if 3050 psi or 21 megapascal concrete masonry were used in conjunction with type N mortar, the maximum specified compressive strength that could be used in design would also be 2000 psi or 13.8 megapascal. Note that compressive strength of masonry values must be multiplied by 85% when the unit strength is established on units less than 4 inches or 102 millimeters in height.
Knowing the definitive terms and the actual application of this topic will surely help us to understand why is it important for an aspiring future engineers like us. Summarizing our topic, the term miscellaneous materials refers to the different elements within a structure that also has different properties and functions. Next, the reinforcing steel, which is usually called rebars. The main idea of this reinforcing is to use steels to strengthen or heighten up the resistance of a structure. In given example, walls, beams, columns, and etc. To actually assess if the steel reinforcements helps to upgrade the structure, the side steel will undergo processes such as different testings like tensile strength test and many more. Then the concrete masonry unit, CMU, it refers to a type of concrete where it consists of hydraulic cement, water, and aggregates like stone and quartz. It can be either a hollow concrete or a solid concrete. CMU are also classified into 3 weight classifications: the lightweight, the medium weight, and the normal weight. The CMU associates with these 2 factors, the absorption and moisture content. As the CMU absorbs water, the mass increases through the percentage of its dry mass. On the other hand, the moisture content of CMU allows it to have relative humidity that helps the material to be tightened up and to have longer longevity. It also undergoes the process called compressive strength, where it will verify if the measurements will comply to the standards. Lastly, the data will be gathered by testing procedures and combining it with the standards to produce a highly efficient and durable material. That's all from our topic. Thank you!